Can we start by summarizing what we have discussed yesterday? Just a couple of points of what we have discussed.
We discussed about multi-threading, a feature that allows execution of two or more part of a program simultaneously. And we have two types of thread. We can create thread using two ways, like thread class and runnable interface. Yeah, I just have that from yesterday, actually.
Okay.
And also we discussed about throw exception.
Okay. Okay. Right. So thank you for that. Just to add few more points, right? Like we started discussing about the exception handling concepts, the difference between throw and throws keyword, right? Like throws is used to tell the caller of a method whether that particular method is going to throw any exception, right? And we'll put that in the method signature so that whoever is calling a certain method, they will be aware that method is going to throw certain exception, and in the code they would be the call to that particular method would be surrounded with a try catch to handle any exceptions thrown from that particular method, right? So that's what throws keyword is for. And throw, it is just to throw any sort of exception, right? Like just to throw an exception upon certain condition is met, we can use the throw keyword, right? We can use it anywhere. So wherever, if it is a caller of the method or it is within the same method, if you wherever you have corresponding try catch enclosed, that would be caught, right? And then we spoke about user defined exceptions, how we can we can create custom exceptions, right? So how can we create custom exceptions? How can we create this?
By creating a class, custom class exception.
Right, by creating a class, that class should extend exception class, right? And we should provide a constructor for the class which will have a super call to that super call, which is basically which would call the exception class constructor. Okay, so that's how we can create a user defined custom exception, and we can throw it, which we saw yesterday, one example of that, right? Creating customer exceptions. Like I said, in our day-to-day work we will be creating a lot of user defined these sort of custom exceptions. Okay, having said that, and we start about speaking multi-threading concepts. We understood what is a process-based multitasking, which our operating system does, and in Java we are specifically talking about multi-threading, which is basically thread-based multitasking. Like within a process there can be multiple threads which can do many things simultaneously within a single process, right? So that's what we started discussing about, and we were talking about how can we basically implement Java multi-threading in the context of, suppose you have a big program, and how can you execute some some chunks of the program parallelly, right? Using multi-threading is what we are going to talk we were talking about. And whatever thing that has to be executed parallelly or defined in a context of concurrent or multi-threading execution, we have two ways, right? Like we would define a thread either by extending a thread class or implementing a runnable interface. So both the thread class and runnable interface have this particular method called run. Okay, so you're in runnable interface, you will be having an abstract method called run, run. Okay, and similarly in the thread class you have this run method which we will override, right, and provide the code which we want to execute concurrently. Understood, right? Like you create one class, either the class will extend your thread class or it will implement runnable interface. It can do any of the both options are there, either or we will choose one. But the idea is both will have this run method. If in case where you extend thread class, you will override this run method and you define the code in the run method which you want to execute parallelly. And similarly, when you implement the runnable interface, you have to provide implementation for run method, inside where you will provide the code which has to be executed concurrently, right? Understood, right? Any confusion here? Any confusion here, guys? We'll just see a demo probably that will clear you or probably give you some more idea, right? But if you ask which one is the preferred approach, extending a thread class Okay. So we are talking about which would be the best approach, right? Whether an extending thread class and or implementing runnable interface. What do you guys think? What do you guys think? Which would be a best approach?
No idea.
Just take a guess, probably. Extending thread class or implementing runnable interface. Like both approaches will work, but which would be preferable? And why do you think so? Actually, they ask this question in interviews quite a lot, right?
Thread class. Looks like thread class.
Why thread class? Why do you think it is thread class? Any reason?
Because we can create multiple threads.
Why runnable interface can't create multiple threads? We can create, right?
Yeah, I think I'm not sure.
Any other answers from anyone? Okay, think from this perspective, right? Think from object-oriented principles perspective, which would be a better. Hey, hi everyone. Am I audible?
Yes.
Yeah, see, it looks like see there is a current here rainfall here, guys. So the power was coming on and off. So the next time it disconnects, thing that will stop the session here. Okay, uh, like probably will continue tomorrow. Yeah. If the next time it disconnects from my end, think it as end of session. Okay, we'll connect tomorrow. Okay. So let's just continue, right? I was talking about best approaches, whether it's a thread class or a runnable interface. So ideally, the best approach is always runnable interface because it's an interface, so you can implement the abstraction concept of object oriented principles, right? Like you can implement more interfaces, but when you come to extending, you can extend the thread class, you can extend only one class. Java has that limitation, remember? So if you extend thread class, then you won't have a feasibility to extend other classes, right? You guys understood me, right? So if we have option for interface, then we will implement the interface only. So, and we will provide implementation for run method, because we can extend some other class for some other functionality, right? So we will be like open to extension. You guys are understanding, right? So for that context, implementing runnable interface is always a better approach. Like in Java, they say, right, always code to interface to have a abstraction in your application, right? So we'll use runnable interface, okay, which is a preferable approach. Understood, right? Like why thread class and why not thread class and why runnable interface?
Can you explain one more time?
Okay. See, in Java, if you extend thread class, right, you cannot extend any other classes, because Java has limitation of extending only one class at a time, right? But when it comes to implementing interfaces, it can implement many interfaces, right? So that's the first reason to choose runnable interface over thread class. And second thing, in Java, in object oriented programming, we have abstraction, right, which is basically nothing but code to interface, make use of interfaces, right? So that's why we will prefer a runnable interface over thread class, because of these two concepts, right? If at all we implement runnable interface, we are open to extending other class in future, right? So that's the reason we will prefer runnable interface over extending thread class. Understood?
Mhm.
No, still not clear, is it? Hello?
Yeah, I mean, can you give us one example or?
No, which part you didn't understand clearly? I mean, I just gave you some statements, right?
Yeah, the theory I got it. Just
Yeah,
practical.
like which part you kind of confuses you, Suman? Which part? Do you are you aware of the interface concepts when we discussed that we can extend only one class, right? Yes or
Yeah,
no?
yeah.
Right. So let's take one. I have this thread T class which I already created. Okay. So I have this thread T class and it is implementing runnable interface. Okay. So that when I implement runnable interface, I have to override this run method, inside which I'll provide the code, right? So the code here is, it's just a for loop where I'm printing numbers from 5 to 1, 5, 4, 3, 2, 1. That's it, a simple code, nothing much. Okay. And it will sleep for 1 second before printing every thread or every value. Okay. That's a very, sort of a simple program. Okay. And if you see, I have created a constructor for this class, and I'm creating a thread object here, new thread, and I'm calling the start method. Start method would create a new thread and would basically execute a thread. Okay, whatever you provide in a run method will execute it. Okay, now coming back to the same question earlier, right? If you remember, what is abstraction in object oriented principles? Can someone tell it again? What is an abstraction? What is abstraction, guys?
It's the process that hides the complexity of the application.
Right. So that means
And
we should expose only interfaces, right? To outside world. We should not expose concrete classes. Yes or no? Using interfaces by the concept of runtime polymorphism, we will call methods, right? Rather than using direct class reference and creating an object for it. Yes or no? That's what it is, right? Abstraction concept. So that's why it is always preferable to use interfaces rather than thread class. So suppose here I am extending thread class, okay, and then I will override run method, okay. Wait. I will override run method like this, okay. Here I'll provide multi-threading code. Can I extend another class like this? For example, you have this box class, for example. I want to use this functionality. Can I extend box class? Is it possible? Is it possible?
No, one at a time, one.
Is it possible or not? It's not possible because Java allows extension of only one class, right? There's if you like, whoever has dot, please speak up, right? Like at least I understand you are understanding something, right? Like yes or no? In Java there is a limitation. This is not limitation created by you and me. Java as a programming language itself has that limitation, right? Can we extend another class? It's not possible. Yes or no?
No.
So how about instead of extending thread class, I will extend box class. At the same time, I will also make this multi-threaded. I'll implement runnable interface. So now I can use extension and also runnable interface at the same time. The moment I add runnable interface, I can override run method and provide my multi-threaded code here. So that means when I'm implementing runnable interface, I am open to extension of another class, right? That's why implementing runnable interface is a choosable approach rather than extending thread class. Understood? Is it understood, guys? Now?
Yes.
Yeah.
Yeah.
Okay, fine. So now coming to the sample, I'm just creating one sample thread code. Okay, if you see the code here, let's start with the moment I create runnable interface, I need to create a run method, right? So here I'm just trying to print the thread state. Okay, and control Z, yeah. In the next set of lines, if you see, I created a for loop, and within the for loop, I'm just trying to print the value of I, if you see here, right? 5 starting from 5 and I minus. So that means 5, 4, 3, 2, 1. The moment it is 0, 0 greater than 0, condition and fail, and it will come out of the for loop, and it will print this thread t. The name of this thread class is called thread t. Okay. So here I create one constructor for that thread t, one with being one input argument. Okay. And this will basically this name is nothing but will assign some name to this thread t, and it is going to so normally you have run method here, right? To actually execute, to create a thread and execute it as a concurrently, you need to call this start method. Start method will in turn call it's a static method. Okay, it's kind of a static method. I mean, it's not static method as such, but it kind of from start method internally it will call run method. Okay, when you call start method, this is how thread is implemented. Okay, like you no need to call, you shouldn't call run method directly. Okay, you should call start method, which is available in your thread class or runnable interface. That method is already available. Okay, so from start it will automatically call, when you call the start method internally, it will call the code present in run method. Okay, so in run method, after printing every value, I'm putting the thread to sleep for 1 second. If you see here, right, just 1000 millis, which means 1 second I'm putting it to sleep. Okay, So, and this may throw an exception. That's why we surrounded this thread.sleep in a try catch block. Okay. You guys understood this code, right? Something in this which you haven't understood, just let me know. Here, or is it not? Whatever that is written in this class. Is it clear, guys? I'm just showing to you the code again. Take a moment, take a look at it and let me know. So to basically create a thread object, you would always need a reference, right? So I created a thread class reference T, and I'm creating that object new thread. Okay, and I'm calling the start method, and this particular start, when I call this start method, right? So this particular thread will have that reference, right? So if you see here, I created another static public static void main class. Here I'm creating an object of this thread_t class. Okay, new thread_t, and I'm passing the name. I'm calling this thread as T2, for example, right? The moment I create a thread like this, the constructor has already code to t.start method, right? So I'm just executing this, then we'll talk further. I'm just executing this, what will happen, we'll see. If you see, right, for every 1 second, 5, 3, 4, 2, 1 values are printing. I'll just show this again. Calling T2. Okay, calling T2 and thread T2, we created an object. The moment we create an object, within the constructor itself, we had a, within the constructor thread T itself, it printed this first line, right? Thread T2.state1. Here the moment when you created the thread, it has a state called new, and then it called the thread. Okay, and then when we are printing the state, it went into runnable, right? And when you call t.start, the execution will start from run method, right? So within the run method, this line got printed, state3 runnable, and now it entered for loop and it executed this line number 20, right? So which is basically printing the value of 5, which is 5, and then it came here thread T to state 5 here, which is again runnable. It went to sleep for 1 second, and again it printed the state here, which is again runnable, and again it finished this entire thing. Now it decremented the I value, printed 4 value, again it printed this statement, it went into sleep for 1 second, this statement, and again it came here, printed 3, likewise, and finally after this for loop is completed, it printed this last statement, thread T turn, which basically finished the execution of our program, right? Have you guys understood how this program got executed?
Yes, but how? What's the purpose of, like, how is multi-threading actually? I think I didn't understand clearly.
Yeah, see, I'm just giving you one basic example. Still, we haven't seen something
Okay.
that is happening concurrently. I'll come there. Okay, slowly. I'm just talking in terms of one thread, how it works, so that when we have multiple threads, we can understand how is it actually going to do multi-threading. Okay, we will be getting there, Asha. Okay.
How?
Yeah.
Question. So when we use like timer put the sleep or like thread.sleep, so in situation do we do I mean if we I mean in the real time example how we do that thing, I wanted to know in the real time example something like that.
Yes, yes. I'll come there. Like I'll give you multiple threads. Okay. So for now, if I comment this, I'm just putting the thread slick for the sake of demonstration only. Okay. If I comment that complete code, let me just execute this again. Okay. Now, if you see, it printed these two statements, and then it came here. It printed 5, 4, 3, 2, 1. Like you didn't even see thread pausing. It executed immediately, right? To give you a feeling that it is executing slowly, I kind of kept this. I'll just probably, comment this states for a while. Let's see. Okay. Because of the thread statement, you can see something is pausing for a second. Yes or no? You can feel that, right? If I don't put this thread dot sleep, then it will just, the execution will finish in a jiffy, right? It will just finish just like that. Let me just, when you have something like this, execute this, it executed almost instantly, right? So just for the sake of demonstration, we will try to understand that, Asha.
So
In case
this means I mean thread dot sleep makes a program little slower. I mean,
yeah. See, whatever thread that is executing this program, it will went into a sleep state. It's like a pause state. You can think it of a pause state. Okay.
So why we use that when we wanted to work a little faster, we wanted to use little fasting thing. So I mean, execution delay means program delay. Program delay means your work delay. Am I right? So why we can use little faster thing, or just wanted to use that way to make a program a little more smoother, or what?
See, thread.sleep, I'm just showing you or probably explaining capabilities of what thread can do, but in a real-time scenario, suppose you have timer-based functionalities, right? Where it, for every 10 seconds you have to check for something that is happening or not. How you will implement it? This is the best way, isn't it?
Okay.
For every 10 seconds periodically, your application has to do something, right? Like a scheduling thing, or probably for every 10 seconds, or after, for example, after sending out certain request, it should wait for 10 seconds. After 10 seconds only it can expect a response, right? If you don't put your thread to sleep, it will be holding the CPU time, yes or no? Your processor will be locked to that thread waiting for that response, right? If you put that thread to sleep for 10 seconds, then your CPU is released for other thread, yes or no? Processing time. So you are using your processing power efficiently there, right? Got my point, right, Asha?
Yeah.
Those are some of the.
So I have a question.
Yes.
So suppose if there is a suppose any program and I mean it is running, and when you put the thread dot sleep, I mean there is a scenario like these the first task should be completed, then only the second after a few seconds the another task is gonna be running. So we can use that in that scenario or no?
See, yeah, kind of. See, that's a different thing altogether. So the context
Like
here
there
is
is a first task, it needs to be completed, and then the another if we do not execute the first
right.
task, then there gonna be problem, but it should be first task should be completed, then only the second task should be completed.
See, for that you don't need multi-threading. You know, right? Java executes sequentially, one thing after the other. So there is no problem of implementing that way, right? When you have multiple things happening simultaneously, then only you will have a problem where you should you should ensure first step is completing before second step, right? When you are thinking sequentially,
Yeah.
there is no such problem. Yes or no? See, the problem you are saying will come in case of multi-threading. How we will achieve, I'll tell you it later. You have something called a join, okay? Where in that scenario, like suppose you started 3 threads, okay? Step 1 thread, step 2 thread, step 3 thread, you executed simultaneously, okay? But you want step 1 to finish first before step 2 gets finished, right? In that scenario, threading has some approach called join, okay? So when you call join on particular thread, what it will do, it will finish that thread, then only it will kind of finish the other thread. It will create that sort of link. In case of multi-threading,
Guys, class done or what? Hello?
Is disconnected.
So that's what he tell us, like once disconnect next, we can done class. It will be done. That's what he meant? Oh.
No, his Wi-Fi is slow, so that's why he is.
No, he told, that's my understanding. Once you next time disconnect, we think we have to understand that class is disconnect and he will become tomorrow and then we join again. That's what the mean. My understanding, I don't know. That's what I'm asking.
No, I don't know either.
Yes, he said like next time he dropped out of the class, then we can just. He's not coming back.
Okay, then we can drop.
It's already been. This is like third time it happened, so there's no point of like rejoining and then dropping.
Yeah.
Okay.
Okay, guys. Bye. Good night.
Let's drop that.